Hi everyone, welcome to our event. This event is brought to you by DataTalks.Club, which is a community of people who love data. We have weekly events and today is one of such events. If you want to find out more about the events we have, there is a link in the description. Go there, click on this link and you'll see all the events we have in our pipeline, which is not a lot because it's summer and everyone is on vacation, but there will be more. So we are working on that. Do not forget to subscribe to our YouTube channel. Very important. This way you will not miss future streams, awesome streams like the one today. And we have an amazing Slack community where you can hang out with other data enthusiasts. So check the link out. And during today's interview, you can ask any question you want. There is a link in the live chat. It's pinned. So click on that link, ask your question, and we'll be covering these questions during the interview. And right now I will stop sharing my screen. I will open the questions we prepared for you. And if you're ready, we can start.
Let's go.
Okay. This week we'll talk about ways to put LLMs, large language models, in production. And we have a special guest today, Meryem. Meryem is a recovering physicist, very interesting, and the co-founder of TitanML. So TitanML is an NLP development platform that focuses on deployability of LLMs and allowing businesses to build smaller and cheaper deployments of language models. So welcome to the show.
It's lovely to be here. Thank you for having me.
Yeah, our pleasure. So the questions for today's interview were prepared by Johanna Bayer. Thanks, Johanna, as always, for your help. And before we go into our main topic of LLMs, let us start with your background. Can you tell us about your career journey so far?
Sure. So as you said, I started my career actually, in physics, specifically theoretical physics and philosophy. That's what I studied at Oxford. When I left, I became an investment banker, which I really enjoyed.
That's quite a change.
Well, mainly because I had a fantastic boss, but I left investment banking to join tech and tech startups. And the reason I did that is because I realized what I actually really love is building things and building products and systems that people and users specifically really like. And that's why I've been in the tech ecosystem ever since. So we started TitanML a couple of years ago now, before ChatGPT. So we have the clout to be able to say that. And we originally started TitanML as a research project coming out of my co-founder's research at UCL, thinking about the deployability of computer vision models. And then we pivoted over a year ago to focus on the deployability of large language models. And that's what we've been working on ever since.
Mm-hmm. Okay. That's quite an interesting career, like working in physics and philosophy. And I was like, when you mentioned that, I was like, how does it even work? Like, what's the intersection between these two? And then, yeah.
Yeah, I mean, physics and philosophy is super interesting. And the way that I say that they're related is they're actually trying to solve the same thing. They're trying to solve, like, how does the universe work and how should we understand it? But they're just going about it in really different ways. So there is actually a really nice intersection.
Mm-hmm. I never thought about this from this angle. Yeah, interesting. But then you worked in investment banking, which is like a completely different area. I don't know, maybe your background in theoretical physics did help? Did it actually? Or it was like a completely new universe?
Other than the fact that I'm really good at maths, not really. So no, I learned everything completely from scratch when I became an investment banker. I think one of the streams that's followed me throughout my entire life is I just like doing things that are pretty difficult. And I learn pretty quickly. So moving from, theoretical physics gave me a great thinking base, a great mathematical base. And that meant that when I became an investment banker, I was able to learn pretty quickly. And I had fantastic people that I was working with and a fantastic boss. And I just like the fact that investment banking was difficult or, was something I had never done before. So I was really excited to see my team.
So what's the most difficult thing? Theoretical physics, investment banking, or being a startup co-founder?
It's a great question. I think they're just different levels of sleep deprived. I think being a co-founder is probably the most difficult thing I've done. Not necessarily because any individual thing you do is difficult, but you are just spinning so many different plates all of the time, and you have to constantly be thinking about everything. So that's probably the most difficult thing that we've been doing so far. So I don't know what my next one will be.
And the main difficulty is like this variety of things. Like you have to do pretty much everything. What's your like official title? Are you a CEO, CTO, or do you have a title?
So we don't really do titles within our org. We have three co-founders, and we all look after different parts of the business. So Fergus looks after product development. Jamie looks after product strategy and also research angle, and then I look after operations and commercial and fundraising. So that's the kind of way that we split ourselves.
But you don't officially have a title of, I don't know, Chief Fundraising Officer.
No. Well, we always get asked this, and I'm like, it doesn't really make sense to have these really grandiose titles when you're still a startup. I think the thing that's important is that you just have like really clear division of labor. We'll get to the point where we'll have like really official titles at some point.
Probably in half a year, you will be doing a different thing, right?
Yeah, exactly. Because things always evolve, and like the challenges are always really different. Like, for example, we're doing way more on the commercial side than we were doing a year and a half ago. And we're doing less on the fundraising side now. So it's ever changing.
And I know we're kind of late to the party of speaking about LLMs, because this is, as I mentioned at the beginning, this is actually our first event ever about LLMs where we explicitly talk about them. And LLMs are large language models, in case you live under a rock and have not heard about them. And yeah, we're quite late to that. So finally, we're catching up and talk about them. And you mentioned that your startup, your company, TitanML, you pivoted from CV, computer vision, to NLP, to large language models. So apparently you're quite interested in them. And I'm wondering, how did it actually start for you? Like, how did you become interested in LLMs, even before ChatGPT?
Yeah, so it was actually driven by our customers. So we were interested in deep learning and were interested in all of the cool things it could do from a computer vision point of view, from a large language model point of view, and from various others. And we were interested from like, the technology level. But we started getting interested in large language models from an application point of view and from what they could really, really do for society. When our customers kept on saying, okay, computer vision is kind of cool, but actually the thing that's going to change our business is language modeling. And that's when we really started getting interested in that particular space. And, part of the reason, they were telling us, this is way more important is because there's way more text in the world than there are images, or at least from an enterprise setting. And that's when we really kind of switched our focus. And then personally, I got interested in them, I think, when I was playing with GPT-3 a couple of years ago. And it was super impressive to see the rate of improvement that we got from GPT-2 to GPT-3. And from a personal point of view, that really told us that something special is happening in the language modeling space.
Yeah, to be honest, for me, these demos, when I saw GPT-3 appearing, they were kind of, okay, cool, but wasn't like, wow, this is going to change everything. So for me, it was like, okay, whatever, like cool that these things exist, but but when ChatGPT appeared, it was mind-blowing for me.
Yes. Yeah.
Even though like tech is still the same, right?
Yeah, and it was for us as well, and we were already involved in the space. But there's something, when we moved from GPT-3 to GPT 3.5, and you could have a conversation with it, and, it kind of felt like there was another really, really smart person behind the screen, and it wouldn't say a lot of really, really stupid stuff. And it felt like that free-flowing conversation of that with just a person that knows everything. It was huge. It was so, so, so amazing. Because before with GPT-3, you had to do a lot of really clever prompting to actually get it to do the thing you wanted it to do. So when we moved from you have to do really clever prompting to you can just have a conversation with it, like that's a huge mindset shift in how accessible and relatable these systems are. So even us in the space, when we saw ChatGPT, we were like, this is going to be huge. We saw it on the first day it came out and we were like, this is going to be really huge. And then it was. So that was really exciting.
Mm-hmm. And what is an LLM? What is this thing actually?
Yeah, so I mean, LLMs are large language models. I would kind of distinguish large language models into two things. So quite often we conflate these ideas. So large language models, as we typically talk about them, are generative models. So what these are models that are able to generate human sounding or like convincing text. And then there's also language models, which are understanding models. So the way that I think about these is these are models that are really, really good at understanding text and understanding language. So we have these two different kinds of language models. The state of the art for both of them is held by transformer architecture. Although, I'm not going to get into the nitty gritty because you can go and read the transformer papers themselves. But that was really the breakthrough in creating the state of the art for both of these. So when we think about language models, I tend to differentiate between generative and then those non-generative models.
And ChatGPT is a generative model, and GPT 3.5. Mm-hmm.
They're both generative, and then you might have heard of models like BERT or Roberta or Electra. Those are non-generative models that are very, very good at like classification tasks and natural language understanding tasks.
So if I need to classify, I don't know, the intent of a search query, like whether the customer wants to buy something or just make research, then I would go with BERT, right? I would not necessarily go with a generative model because it would be an overkill.
Exactly.
Mm-hmm. But I would still be able to use an LLM saying, hey, I have this query. Here are examples of other queries. And based on these examples, what do you think is it's like? What intent of this query, right?
Yeah, so those like really massive models like GPT-3 or 4 can also do those classification-based tasks. If you do a few shot learning, you can typically have very good results. The reason why for most deployments we recommend not doing that is because you have these massive models doing these tasks that can be done by models that are in the millions of parameters rather than the billions of parameters.
So BERT, which is a non-generative model, is it a large language model or is it just is it even a language model?
It's definitely a language model. It used to be a large language model. So we used to think of like BERTs and Robertas and Electras, which are hundreds of millions of parameters, as being large language models. Like a lot of businesses still struggle to deploy them at good inference, for reasonable cost. But the GPT-3s of the world have kind of blown that out the water and redefined what it means to be a large language model. So the scales have just completely changed. But BERTs are still relatively big when we compare them to typical machine learning models.
Mm-hmm. And a model, like a usual language model, can still be generative model. It maybe will not have the output that is as good as, I don't know, GPT 3.5 or 4, but it can still generate some text, right?
Yeah, so like there's a whole range and ecosystem of language models, and they have they're good at different things. So for example, there's the Google Flan T5 range, which is able to generate text, but what that's particularly good at is translation and summarization. There are other models like Llama, which is an open source language model, which is much smaller than what they suspect GPT-3 is, which is able to generate text and have a conversation. It's probably not as good as GPT-3 or 4, but it's still a language model that is able to both understand and generate and converse.
So the main advantage of LLMs is that they are better at what they do. They are better at generating text, right? So why do we even care about them? So why you focus on deploying these LLMs?
So why are these important?
Yeah.
Well, they are incredibly powerful when it comes to being able to work within our unstructured language, paradigm. So most of the things that we work with as humans in, everyday work is unstructured text, typically, right? So we write emails, we write documents, we write code, and all of this is incredibly unstructured and actually very difficult for machines to understand. Now, language models is that paradigm shift of being able to create a system that is actually able to understand this unstructured data to a level that appears human-like, or sometimes even better. So that's why it's a huge paradigm shift, because it's, for the first time, really able to work with these documents in a way that humans generate these documents in an unstructured format, and then also generate documents in a similar format. So that's why I think it's a huge paradigm shift, because it's finally able to work within the paradigms of how we normally work, because humans don't normally work in databases, unfortunately.
Mm-hmm. Would be convenient, right?
I mean, it would be convenient, but we don't need to anymore.
Right. And like you mentioned Llama, which is an open source LLM, because like I know with OpenAI, they have all these models, but they are closed, even though like the name kind of suggests OpenAI, that it would be open, but they are not, they are closed.
Don't get me started.
Yeah, I think the reason behind not opening them is that it can make harm in somebody's hands, right? Like if they open, then it will make more harm than if they keep it closed. Interesting. But still, there are models like Llama, the one you mentioned. There are maybe others that are open. Can you tell us more about them? Like what is the main difference between these open models and the models from OpenAI?
For sure. So there's a whole bunch of open source language models, and they're getting better and better month by month. So I think only 2 days ago, Meta released Llama 2, which is a massively improved version from Llama 1, trained on 40% more data. There are other examples like Falcon, which was released, I think, by Abu Dhabi. There's models like MPT, which was released by Mosaic. And these open source models are very quickly approaching the benchmarks and levels and performance that we see set by the OpenAI models, or the at least publicly released OpenAI models. There is still a bit of performance gap, but the beauty about these open source language models is that they are much easier to in-house, fine-tune, train on your data and for your particular use case. So with a bit of fine-tuning and with a bit of training, you're actually able to match or sometimes even beat the performance benchmarks from OpenAI. So these open source language models are getting better and better, literally by the day or by the week. And they allow the user or the business to have control over these language models and really deploy them in the way that they want to, for the use cases they want to, rather than relying on an OpenAI API, which also, as we realized this week, they've been changing the performance of slightly. So there's just a lot more control with these open source models, which is why I am personally most excited in the entire field by the speed of improvement of these open source models. Because as soon as we get these open source models that are on par with what we're able to do with OpenAI, then that's a huge that's a huge paradigm shift for how we think about how we build and deploy these models.
What actually happened this week? I saw a couple of posts in social media about the drop in performance of GPT-4, but I don't really know any details. What happened?
Yeah, so I had actually noticed this a while ago, that I used GPT-3 and GPT-4 a lot. And I had noticed that it felt like it wasn't as smart as it used to be. And I put it down to two things. Either they distilled it a whole bunch and, they just tried to save more compute and made the model worse. Or two, which I thought was potentially more likely, is I was just getting used to what these models were able to do when I wasn't thinking they were as magical as I thought they were 6 months ago. But a paper came out recently by a group who had been secretly kind of benchmarking these models' performance over time, and benchmarking it for various hard tasks. So one of them was asking whether a very, very big number was prime. And earlier versions of GPT-4 were able to answer this with like 97% accuracy. And the latest version of GPT-4 was able to answer this with much, much, much lower accuracy, like, I think less than 10%. And what that showed is that OpenAI had been changing the models without the user's knowledge, which is super problematic. Firstly, because OpenAI had been denying it for ages and ages and ages. And secondly, businesses had built products off of these OpenAI APIs, and these models were changing behind the scenes without their knowledge. And so their products were changing, likely deteriorating over time without their knowledge. And that's hugely problematic. And I think this goes to the idea of like, if you're building AI systems that are important to your business, you need to be able to have control and visibility of actually what the systems are doing. And that's why I think it's important that we use open source models when it's business critical. And that also when you use models from OpenAI, you don't own the models, you're being leased them, and they can change them or they can remove them at any point. Like a couple of weeks ago, we saw OpenAI stopped running a whole bunch of their legacy models, which meant that anyone who was running applications on top of these legacy models had to change their architectures and switch over and potentially change prompts. So it was just kind of this realization by the community that building models on top of OpenAI, although it's really easy and very easy to get going, does come with these limitations of you don't actually know what they're doing with these models behind the scenes. So you have to be careful there.
So from what I understood, so as a user of OpenAI API, I have an endpoint, a URL that I use for sending requests. And in the request, I say like, okay, this is prompt, this is the model I want to use. And I send requests, but what happens under the hood is the URL still stays the same, but behind the scenes, the model actually changes. So I keep sending the same requests, but yesterday it was one model, but today it might be a different model that is serving this request, that is answering. And I have no control and I have no idea that this happened, right? And at any point of time, they can just go ahead and change, maybe take a GPT-4 model and use a distilled version of this model that may be better for them because like it's faster, but for me, like the performance of my application drops, right? And I have whatsoever no control over these things.
Yeah, and I think it's completely right that they are trying to distill these models. And I think it's right that they're trying to make them cheaper and faster. And they also are constantly fine-tuning them over time to make the performance better, once they get more data. But the user needs to be able to know that and be able to say, oh, I do want to switch or I don't want to switch. Because when it happens behind the scenes, you just have these users who are like really confused that, oh, my application's not working like it was, 2 weeks ago. What's happened? So that's why I think it's kind of problematic.
Mm-hmm. And in case of open source LLMs, let's say we take Llama and we host Llama with Titan or whatever, some other tool, right? And then the model stays the same all the time until we want to change it, right?
Exactly, because you can go in and check the weights. You can go in and check that the model is the exact same. Mm-hmm. So you can only, upgrade your model when you want to, and in ways that are appropriate for you and your business. Like you can say, oh, my application's not fast enough. Let's look at distilling it or pruning it or whatever. But that's something that you control and you can version control that. Whereas you can't do that with the APIs.
I kind of assumed that what you do is hosting open source models. I don't know if my assumption was wrong or right, but maybe you can tell us what you actually do at Titan.
Sure. So what we do is we help businesses build and deploy language models for their particular use cases and their data and their tasks. We do host open source language models that have been fine-tuned, but actually a lot of our customers want to host these models on-premise or in their own cloud, so they can have data security and privacy. So we have 3 offerings. We have the Titan Train offering, which fine-tunes large language models for particular use cases and particular domains. We have Titan Optimize, which is for natural language understanding models, so the BERT-style models. With the Optimize module, we can compress those models very, very significantly by 10 to 100x. And then our latest offering, which we actually released on Monday, is called the Titan Takeoff Server. So this is a massively optimized inference server that businesses can use to deploy large language models on premise, even on CPU or on their data center with really fast inference and low costs. So those are our kind of 3 offerings, and we help businesses train and then deploy those large language models, or we can host it for them as well, which we've done before as well.
So as I understood correctly, previously you were mostly focusing on training and fine tuning, but now you're also moving in the serving space for LLMs.
Yeah, because the serving part is really difficult. And
they're large, right?
They're really large. Like that's, why we got into the space originally, is we were working on the compression of these deep learning models. They're really difficult to serve. So there's a huge amount of value that can be added by just making that infrastructure easier. So that's kind of, and also everything we do is about making infrastructure easier. So fine tuning is also really, really hard because, as you say, they're large. So the serving infrastructure is an extension of us making that infrastructure easier as well. And what it means is people need less GPUs, which is nice.
Okay, and I have a question here about use cases, and I'm also interested in learning more about fine-tuning. So I was wondering, maybe you can give us a few use cases and how exactly fine-tuning helped there, and what is fine-tuning doing for these cases? Why can't we just take off-the-shelf LLM model like Llama and just use it for whatever we want to solve? Why do we even need to fine-tune?
For sure. So when you take a model off the shelf, what it has and what it's very, very good at is like general language knowledge and understanding. So your model will speak English or speak whatever language it was trained in, and it'll have reasonably good grammar, and it'll have reasonably good knowledge about the world. But what it won't have is any domain-specific knowledge or any kind of company-specific knowledge, or it won't talk in the tone that you want to do. So the process of fine-tuning, I like to think about it as the process of specialization. So you have this really general big language model. How can we take that and specialize it for your use case in your business? So we end up with a language model that's bespoke and works well for you. So it doesn't just have okay accuracy and performance on everything. It has really, really, really good performance for the thing that you care about, and probably okay on everything else. So that's what I think about when we think about fine-tuning language models. So I can give you a couple examples. So if we think first with the natural language understanding tasks, here fine-tuning is necessary. So if we want a model that classifies intent or is some kind of classifier, you need to fine-tune it so it understands, what your labels mean, or what kind of text is it expected to see. So once you can fine-tune a model to classify for whatever it is you need to classify for. For the
here fine-tuning means here is a set of examples, input text, output label. Please adjust the weights in whatever way you want, in such a way that we get the best performance possible on this training.
Exactly that. And the key there is getting good data. So if you can get good examples of the kind of thing you want it to classify and what correct looks like, then you'll get a really good fine-tuning result. It'll adjust the labels in a really good way. The way that you get that wrong is if you have bad data or not enough data, then it makes fine-tuning much harder.
Here, usually we talk about classification, right? Intent classification, sentiment classification. I don't know, like basically we have some text as input, and output is a set of labels, right?
Exactly. And then we can think about, so if we think about fine-tuning for more generative language models, one really good use case that we see for fine-tuning generative models is it's very hard, for example, to get a generative model to speak in a particular tone of voice or in a particular style. And that's very hard to get working with prompting. So
what do you mean, a particular voice or style? Like you mean more colloquial or more formal, or?
Exactly. Or like maybe you're training a customer service agent, and you as an institution or a corporate have particular brand guidelines and particular ways of speaking. You can fine-tune a large language model off of examples of conversations that your customer service agents have had in the past, and it'll start mimicking that style of voice and that kind of tone. Like that's a great example of
with ChatGPT, sometimes it speaks too formal. And then I say, hey, it's too formal. Can you make it less formal? And then it speaks like a teenager from Reddit.
Exactly. It's so hard to get it to speak kind of like normally. I find that as well. But fine-tuning is a really good way of getting around that. There's also other use cases you can do for fine-tuning. So let's say you work in a domain which has a lot of domain-specific knowledge. So like finance is an example of that. You can fine-tune an open source language model or a language model on information from your particular domain. And what that'll allow the model to do is start understanding phrases from your domain that might not have been in its training set. So for example, let's say you work in the finance industry, you want your model to think that a bear market means something to do with the financial markets and not a market where you're selling bears. It's those kinds of things that you can do with fine-tuning that really allows to get this domain adaptation.
Mm-hmm. Yeah. An example with market selling bears, because that's what I would think.
Exactly.
How does this process of fine-tuning look like for generative models? Because for these BERT style models, as we discussed, it's more like you have this input set of data with labels. Here you go, adjust your weights based on that. But for generative models, how should the data look like for us to fine-tune?
Yeah, and this kind of changes depending on the end task that you want it to get it to do. But in cases that we've done, you can literally just have like streams of documents. You can just have raw text that you can fine tune it on. So you don't need to have the super structured format of like the before and after that you need for the understanding models, unless that is what you wanted to do in the end.
So you said it depends on the end task, and I was wondering what kind of end tasks are actually there.
Yeah, so like summarization is a good one. So, where you have a long passage of text and you want to say, okay, well, just give me the gist of this 5-page document. Summarization is one. All of the natural language understanding tasks, you can also mimic with generative tasks. Another might be a tone change. So I can ask my generative model, can you give me a before and after for, with the right tone and without the right tone? And then all of the other kind of ChatGPT kind of tasks like, knowledge retrieval and just generating text are all the kinds of things that you could do with these language models. I like to think that, anything that you can kind of do with text full stop as a human, you can probably get working with a large language model.
Yeah. A few days ago, I read an article about a copywriter who lost her job because of ChatGPT. And yeah, at the beginning, she was getting just like instead of 10, I don't know, 10 articles per week or whatever, 10 articles per week, she would get 8, then 6, then 4, then 2, and then nothing. And then eventually she lost her job. And then one of the jobs she found was training another language model to replace copywriters. So I think this is what you said, like generative, like end task can be generative. Like I want to generate text in a particular way. So then I need to hire a human who would produce text in the way I want. So then we can fire this human and just use the model.
It's like, it's a really strange time. And one of the industries that is expected to be most impacted by this is actually engineering, which typically has been very, very safe. And someone was saying to me the other week that engineers are actually replacing their own jobs because they're creating these large language model systems and integrating large language models into their work that actually in 10 years will largely replace what they do, which is kind of interesting. So yeah, there's huge ethical implications for what we're doing.
Yeah. I noticed I tried to use GPT-4 for creating a website in Django. And I would say, okay, this is the website I want to create. These are the tasks I want to perform with this website. Generate me code. And then step by step, it would actually generate me code that I would copy paste to the terminal, to VS Code. And then sometimes it doesn't work. So I try to run, it doesn't work. Then I just copy the stack trace, put it to ChatGPT, say, hey, this is the stack trace I got. And then, oh, sorry, I forgot to mention that you should have done this thing too. So do it now. Then I do this and then it works. And I'm like, wow.
And it's probably like, my guess is that took you way less time than it would have taken you to just do it yourself.
Yeah, like I used Django like 10 years ago. So for me, I would need to Google for like look up many things, but it would just tell me what I need to do, right?
Yeah.
And then I said like at the beginning, it generated me a pip like requirements.txt file, and I was saying, hey, I want to use pipenv, and then oh, here you go. Here's like this is the command you need to run with pipenv. And it's like it just like a person who's doing it for me, and then I'm just telling this person what to do, and then it's doing it.
Yeah, it's crazy. Like we use it, and it definitely massively increases the productivity of our engineers. There are like obviously risks. Like there was a malware attack that I read about a couple months ago where ChatGPT kept on making up packages that didn't exist. So what some bad actors did is they then created those packages and put malware in it. So when you
Ingenious.
exactly, like they would maybe like slightly misspell a commonly used package, and then that then became an attack. So there is obviously risks associated with doing this, but my guess is a lot of these will be ironed out over the coming months and years.
So right now, today, you still need an engineer to kind of see if whatever the model outputs make sense, right? That's why for now, engineering jobs are kind of safe.
Yeah.
Somebody still need to, but what you're saying is in 10 years, it might be a completely different situation.
Yeah, I mean, people have different approaches on this. Some people just think more code is going to get written. So they think in a similar way that we saw a productivity increase when we moved to factory production lines, more cars were built and the same number of people were employed, but we just had more efficient processes. So some people think we're just going to have more code written, full stop. I have a slightly more pessimistic view, and I think that if not in 10 years, then in like the longer term, we are just going to have less software engineers, which is sad. But
I know. What do you feel about this? Because like you're practically building a startup for making it happen.
Yeah, it's a great question. So we don't actually, create any code generation stuff typically. So we don't replace anyone's jobs directly, but we're working in an ecosystem that's going to be really, really disruptive for our society as a whole. And unfortunately, I don't think there's any way of stopping it. Kind of the cat's out the bag. I think as a society, we need to look at ourselves really closely and think, how are we as a society going to organize ourselves when we have transitioned to a post-work society where the majority of people don't have jobs and don't have like productive mechanisms in society. Like we need to reorganize ourselves, and what will that look like? So that's what I kind of think. And I know a lot of people have the contrary view where we'll just have, everyone will be way more productive and it'll be great. But I actually think this AI will get very, very, very good very, very quickly.
I think a few interviews ago, I don't remember what we talked about, but then at some point we talked about a TV show called Mandalorian. In this TV show, one of the episodes was there were a bunch of droids who went rogue, so they started behaving differently, strangely. And the whole society actually relied on the droids to do the work. So people would just sit back and enjoy life while droids do all the work. Right? And I think this is related to this post-work society that you mentioned. And then when something happens with this droid, then they have to hire like somebody to go and fix this problem, because like nobody knows how to work. They rely on droids.
Yeah, I also think like there's a view that, oh, it will be great when we don't have to work, and that'll be wonderful and all of these things. I think people will really struggle to find meaning in their lives and like stay attached to some kind of like, I'm adding value, which I think is really important for the human psyche. So we need to figure out a way that we as humans can like attribute value to ourselves and generate value to society without having to have an official workplace. Because I don't know. I don't know whether if tomorrow everyone didn't have jobs, if people would be happier in the long term. I think.
Sounds like communism.
Pardon?
Sounds like communism.
Exactly. That was like Karl Marx's ideal that we would garden in the morning and paint in the afternoon. But people don't know how to work like that. Like people, as a society, we don't know how to generate meaning without having a purpose in society, and that will be a really interesting transition.
So we're getting a bit too philosophical, and we actually have a few questions, and one of them is related to the topic of fine-tuning. And so here the question is about creating a chatbot with LLMs. So let's say you have 1 million conversations, and then you take these conversations and you feed it to an LLM to fine-tune it, to learn, I guess, the style, the tone of how chatbots should behave, should answer. But then the answers change with time, right? So maybe what is the correct answer today will not necessarily be correct answer tomorrow. Yeah. So how do we deal with this situation? We cannot just go and fire all our customer support agents, right?
For sure. Yeah, that's a really great question. So there's a couple things we can do there. The one that I prefer is using information retrieval. So when you're doing customer service, typically you'll have huge streams of documentation of what the product looks like and what kind of responses are acceptable, blah, blah, blah. And you can
knowledge base, right?
Yeah, exactly, like a huge knowledge base. And I think most companies have those kinds of knowledge base, whether in Confluence or Notion, etc. And what you can do is you can embed all of that documentation and re-embed it every single time it changes in any substantial way, and get essentially look up the right part of the documentation as part of your answer, and base your LLM's knowledge in the truth of what's in the documentation. So that way you can always stay grounded to whatever the base truth is in the docs. Or you could obviously, refine tune, but that's a much more expensive process than just re-embedding this like big knowledge base and this big documentation.
So as I understood, there are two ways of, so let's say we have a knowledge base and we want our model to use this knowledge base in replies, right? So in the same way as, let's say I use ChatGPT to create a website in Django, then, for example, there is a less famous library, like, I don't know, something else that is not widely known, but we have some internal documentation about this. So what we can do is we can just feed all this documentation to an LLM and fine tune it. And then we can ask it, hey, like I want to do this task, how do I do this? And then if we just took all our knowledge base and put it into an LLM by fine tuning it, then it will reply and say, this is what you need to do. But the problem with this approach is our knowledge base changes with time. People go to Confluence, people edit the files there, and we cannot constantly retrain the model. We cannot constantly keep it updated, because I guess it's also not very cheap. It's an expensive thing to do, right? An alternative to that would be, instead of retraining the whole model from scratch every time, we have a knowledge base and we index this knowledge base. And then we try to, like when there is a question, how do I do X with this library, instead of just using the weights of the model, we look the answer up somewhere in this knowledge base.
We'll look the answer up, typically using LLMs, probably using some kind of natural language understanding LLM. Another key reason why I prefer this particular method than the fine-tuning method is you get much less hallucination. So because your answers are grounded in the truth of a particular section in your documentation, you know that that's true rather than it sounds like your documentation. So fine-tuning is much better for like style rather than kind of substance of it needs to say this particular thing. And then you can have the model rephrase it in a way that, you know, sounds conversational.
But usually when I think about documentation that I, as a software engineer, as a data scientist, create, usually I have like a big Confluence page with all the things there. But oftentimes when I have a question, the answer is in a specific paragraph of this document. Yeah. Not like the entire document, but just one part of this document. Then does it mean that I need to be careful how exactly I index my knowledge base? Or how do I go? Like, I guess, like I still need to have some training data to say, like, for this question, this is where the answer is, or?
Yeah, it's a good question. And the open source models aren't as good at this reasoning as those like GPT-4 is. So it's not as good at pulling from 5 different sources and then stitching them all together. However, there are cool things you can do when you do that information retrieval. So instead of it just returning the top 1 answer, you can get it to return the top 5 answers and get the LLM to search for the answer based on, you know, five different sections rather than 1 different section. And what that means is you might get more variety in the answer, and it might be able to pull, let's say if your answer can be found in 3 different places, it can pull those 3 different sources together.
And how does it work in practice? So do we, because I guess we need to put the entire document in the prompt, right? So we need to somehow find a way that for this question, these are the relevant documents. Let's put them all in the prompt and let the model figure out the answer, right? Or how exactly does it look in practice?
That's one way that you could do it, is you can just essentially inject relevant parts into a prompt. You can say something like, answer this query. You may use the information from these documents or these sections, and then put the sections below. That's definitely one way that you can do it. Another way that you can do it is if you really want to ground it in truth. So if you're very, very sensitive task, you can say, I just want you to pull up the relevant section, and then I just want you to summarize it or change the tone or do something like that. And then you have one model that does the information retrieval, and then you have another model that just does a summarization and is really. Oh, have I gone? Hello?
Hello.
Sorry, my phone.
You're still there?
Yeah. So yeah, that's another thing that you can do, is you can ground it in truth through information retrieval and then put it through a summarizer.
Mm-hmm. Okay. So the next question we have is about a vector database. And before we talk about this, maybe you can tell us what these vector databases are and how they are relevant to LLMs.
Yeah, so these vector databases are very, very similar to the information retrieval systems that I was talking about. It's essentially a way of like indexing these, this unstructured data and being able to search it through natural language. So you could use the vector database as like the first step in order to find the relevant parts of a document that you need to answer your query. So that's like essentially the first part of that system that I was just talking about, the information retrieval part.
So let's say in practice we have a Confluence wiki with all the documentation, right? What we do is we get each document from this Confluence, and then somehow index it with a vector database. So then for each of the documents, we have a vector which we put into the database, and then when there is a query from the user, we somehow turn this query into a vector again, and then try to look up the most similar vectors from the database. Is it how it works, or?
Too much, yeah. Mm-hmm. Very good explaining it. You're much better than I am explaining it.
And LLMs can also, vectorize a document, right? They can take a document and create embeddings from this document so we can put them in an vector database, right?
Yeah, exactly. And vector databases are hugely popular to do those kinds of information retrieval systems that I was talking about. People really love them, which is why they've exploded in the startup scene.
And for this task, do you know if we should go with, I don't know, an open source LLM or go with GPT 3.5 or 4? Like, are there any pros and cons?
Yeah, the way that I tend to think about whether you should use GPT 3.5 or 4 or an open source model is if you are still in the prototyping stage, if you're still at the stage where you want to figure out if a model or an LLM is right for your use case, then you should definitely use one of the API-based models like GPT 3.5 or 4. And the reason for that is you're just able to get to results really quickly. You're able to get to demos within a day or two, which is very impressive. But in the long term, businesses tend to want to use open source models to build their applications for a bunch of reasons. One is like, you actually know the model's not changing under the hood. Another reason is, data privacy. Another is it's much cheaper and faster. All of these really good things. So in the longer term, you can move over from using that OpenAI based model once you've proven out the business case to build something a bit more scalable with open source models. And given that an application works in OpenAI, you can almost certainly get it working to a very similar standard with a fine-tuned large language model.
Mm-hmm. So the benefits of going with an open source model eventually after the prototyping stage is models do not change, data privacy, it's cheaper, and you also mentioned faster. And I wanted to ask, like, faster? Because like for me, these OpenAI models seem to be pretty fast. Like you can be even faster when you host your own model. Can you?
Yeah, I mean, they are really fast. They're really fast because they're hosted on very expensive hardware. If you were to host your model on the same hardware, using good techniques, so like using something like the Titan Takeoff server or other like fast inference servers, you can get very fast models on very powerful hardware. But what is also really nice is that most businesses aren't deploying their models on the state-of-the-art, very expensive hardware. They're deploying it on smaller GPUs, like smaller GPUs or even CPUs, because that's typically what they have available. And these models will be much faster than what you would be able to do if you're hosting like an OpenAI model on that kind of server. So you can get it even faster if you use really powerful hardware, or you can just get comparable speeds for much lower prices.
But you have to put some effort. You cannot just take, like in case of OpenAI, you just take a off-the-shelf API, right? And then you start using it. Of course, you pay, but you can move very fast. But then at some point, you start thinking about costs, data privacy, and other things. And this is the time when you invest time in open source, in adapting, adjusting open source model.
And it's the way that I describe it is if you've read Peace Deals 0 to 1, it's this, once you're kind of trying to get to product market fit or MVP or whatever your one is in your case, definitely use whatever makes you move quickest. But in the long term, when you start thinking about scalability and data privacy and performance in the long term, then you can start transitioning over. And it is a bit more effort than just using APIs because they're trivial. However, there are a lot of tools that make it much easier nowadays. So like to fine tune used to be a really laborious process, but it's now much easier than it used to be.
And we have a few interesting questions from Taras. So the first question he's asking is, how can you measure if the data you feed into an LLM is good enough? Do you even think about these things, or you just think, oh, this is the data I have, let's just throw it all in and then it will figure everything out?
It's a great question. How do you know if it's good? Because there's no like hard measure of this is exactly the quality of data that you need. Obviously, the cleaner, the better. And I tend to measure these kinds of things based on the quality of the output. So if the quality of the output is good and exactly what you want, then clearly what you put in was probably fine. When it comes,
Yep, sorry.
When it comes to what you should put in the model, what we tend to find is that it's better to use a slightly smaller sample of what we would deem like gold standard, really, really high quality data, preferably that someone has hand labeled or, at least checked the labels for. And then once you have that, you can use interesting methods like dataset expansion or dataset augmentation to get a large LLM or an LLM to generate more examples from that gold standard data. That typically tends to, for us, in my experience anyway, yield better results than just throwing in a bunch of, rubbish data into there just for volume. That have a smaller amount of quality and then expand it with an LLM.
And data expansion is a strategy, I guess, like in the same way as we use data augmentation for computer vision, like we take a picture and rotate it slightly or crop we basically use existing data to generate more data. Dataset expansion is something similar, but for NLP, right?
Yeah, it's super similar. So like a very basic example is if I have a data set where one example is like the pig is pink, I might get my LLM to say the cat is black, right? And it just like kind of switches words out, but it's semantically similar. Another way that you can do it, which is just much easier, is if you just put in a bunch of examples into an LLM or a good LLM and just say, generate more, data points that look like this. And it actually tends to do pretty well. So we recently did a benchmarking of this. It was called GP Teacher, where we compared the performance of a fine-tuned BERT model off of gold standard data that was all hand labeled versus an LLM augmented version, where we took like 10 examples from the gold standard one and just said, create more like this. And we got very, very good performance for that augmented data. And it was obviously much quicker and cheaper than hand labeling all of them.
And you mentioned good performance, and this is another question from Taras. Like, how do you actually benchmark LLMs? Like, how do you say that performance is actually good? Because like you need to have an objective way of saying that. Because like, of course, you can subjectively say, okay, the answer to this prompt is good, or the answer to this prompt is not good, but it doesn't scale, right? So when you retrain a model, you want to somehow automatically say that, okay, this is good, it's better, or it's worse than the previous version.
It's a really good question, and I don't think it's a solved question. For natural language understanding tasks, it's much easier because when it's classification, you can say it's this % right or it's this % wrong, and that's much easier. For generation tasks, there's a lot of different ways you can be right and a lot of different ways that you can be wrong, and that is hard to systematically measure. We actually, when we're doing projects, measure it by hand. So we will just play with a model for a given amount of time and say, does this kind of look sensible? And that's the most reliable way that we found to really kind of get a feel for quality. And there are interesting things you might be able to do with automating it if you're refine tuning, maybe coming up with like example, benchmark test data sets that you can then go in and hand evaluate. I would always recommend hand evaluating at least some of them. You might also be able to get an LLM to mark it for you, which could be an interesting way of doing it as well. But unfortunately, with the generative models, there's not an easy way to check performance other than to do it by human methods.
So right now, currently with the existing methods, we still need to keep the human in the loop to assess the performance.
Yeah, it's like also partly because this technology is new and businesses aren't used to it. So anything that you can do to make it feel safer or make it feel like it's going to do sensible things, the better. And very often that just takes people to check, like, does this work? What about this edge case? What about this edge case? All of that thing.
So maybe the job of copywriters might be not safe yet, but at least they can be these humans in the loop. But then help eliminate them in the future. Kind of interesting dilemmas. Anyways, well, we should be wrapping up. Maybe before we finish, Is there any good resource, like book or course or blog, that you can recommend for those who want to learn more about LLMs and fine-tuning LLMs and all the things we talked about today?
Yeah, there's a whole bunch of resources. So I follow a lot of, I guess, like LinkedIn influencers in the space. So if you follow me on LinkedIn, I typically retweet a lot of them or repost a lot of them. So you can see a lot of that really great content. There's also cool things like Cohere has a great like LLM university thing. The Hugging Face course is also very, very good. And there's a bunch of really good resources on YouTube. And that's where I would kind of get started. But yeah, it's one of those fields that just has like a lot of scattered, very, very good influences that you can just follow over time.
And this is so rapidly developing, then maybe by the time we release this interview, this episode, there will be a new course.
Everything that I say will be completely out of date within a week, probably.
Well, let's hope at least for half a year it will still be relevant. Yeah. Okay, thanks a lot for joining us today, and thanks everyone also for joining us today. And yeah, with that, I think we will finish.
Thank you so much, Alexi.
Yeah, have a great rest of your week, and bye everyone.